Get ready to have your mind blown as we take a journey to discover the first actual water worlds outside our planet, with oceans that are 500 times deeper than the average depth of Earth's oceans, and might just support an emerging theory of planet migration. In today's video, we will be discussing the recent discovery of two exoplanets named Kepler-138c and Kepler-138d. We will explore the significance of this discovery and what it suggests about the possibility of liquid water on other celestial bodies. Not only will this information expand your knowledge of the universe, but it may also give a new perspective on the possibility of life beyond Earth. The discovery of liquid water on celestial worlds other than our own is something that gets astronomers excited. And in recent years, that excitement has often hit the roof, especially when potentially habitable worlds are spotted in and around the countless stars in our solar system. When searching for habitable worlds, cosmic scientists look for a number of characteristics, but perhaps the most important of them all is the ability to sustain liquid water. We've had many encouraging signs that liquid water could possibly exist on other planetary bodies in the depths of space. However, much of this belief and the supporting evidence is based on hypothesis. As a matter of fact, the only hard evidence of liquid water we've seen outside of Earth was found somewhere in the icy crust of Jupiter's moon Europa and Saturn's moon Enceladus. But if the recent news is anything to go by, we may have just identified the first actual water worlds outside our blue planet. The strange planetary bodies named Kepler-138c and Kepler-138d are considered a first-of-its-kind discovery for different reasons that we will highlight later in the video. According to the official records, both exoplanets orbit a red dwarf star located around 218 light-years away from us in the constellation Lyra. Aside from Kepler-138c and Kepler-138d, this star system has two other planets orbiting it. Those two are called Kepler-138b and Kepler-138e. Compared to its siblings, the Kepler-138b exoplanet is small and rock-like. Kepler-138e, on the other hand, is the farthest planet from the star, which means it needs about 38 days to complete a full orbit around the star, but somehow it is located in the inner boundary of the star's habitable zone. This means there's a chance it could sustain complex life as we know it here on Earth. But that's a discussion for another day, because our attention in this video is fixated entirely on Kepler-138c and Kepler-138d. According to scientists, these two water worlds in the Kepler-138 star system are slightly bigger than our Earth, about 2 to 4 times the size of our home planet, which is why scientists sometimes refer to them as sub-Neptunes, or intermediate-sized planets with relatively low densities. This had been a cause of concern for a while because scientists are not sure if they have a rocky core or if their atmosphere is surrounded by thick hydrogen. The only thing we know so far, at least from new experiments conducted, is that they contain an unbelievable amount of water at outrageous depths. This was emphasized by Li Zhang, a reputable cosmic scientist from Harvard University, who says these sub-Neptunian worlds are not just submerged. By his estimates, he believes they could be several thousands of kilometers deep, much more than the average oceans on Earth. Li further described the oceans on these strange exoplanets as unfathomable, bottomless, and very deep. And reading through their official measurements of their depth, you've got to admit that those are just about the perfect adjectives to describe them with. In fact, the depth of the ocean on Kepler-138c and 138d is so great that it defies human comprehension. For the record, both worlds are believed to have global oceans that are at least 500 times deeper than the average depth of Earth's oceans. For perspective, an average ocean on Earth is over 12,000 feet deep, while the average ocean depth on the Keplers are about 1,250 miles. But aside from the uncommon depth of water located on both exoplanets, this renowned discovery is also bolstering an emergency theory around planet migration. Naturally, water worlds are believed to only exist in the outer regions of a star system. We know this because many sub-Neptune worlds exist in close proximity to their host stars. However, the scientific work that led to this discovery has shown us that planetary bodies, including water worlds, tend to slowly drift inwards over time. Or at least that's what the computer simulations suggest. As mentioned earlier, scientists had speculated that global water worlds like these could exist. In fact, we've had quite a few pieces of evidence to back up this speculation. However, this is the first time we've found concrete evidence that they indeed exist. And it's all thanks to the amazing data provided by the Hubble and Spitzer space telescopes. For better understanding, scientists performed new research to test some of the processes around them. Consequently, they published their findings in the journal Proceedings of the National Academy of Sciences. This groundbreaking experiment was carried out by using ultra-advanced computer models to scrutinize data from a number of NASA-backed exoplanet projects and exploration gadgets. This includes sophisticated devices like the Kepler Space Telescope, which is NASA's main exoplanet hunting device. Furthermore, it required data gathered by Gaia mission, one of the space telescopes belonging to the European Space Agency. More significantly, the models deployed in this exceptional simulated experiment about planet formation processes were influenced by samples of nebular gases, water-rich ices, and various rocky materials, consisting primarily of iron and nickel gathered by scientists over time. Also, the experiment was influenced by complex chemical processes driven by temperature, cooling rates, evaporation, condensation, density, and distance to the host star, among many other factors. And as expected, the results were absolutely amazing and eye-opening, especially for scientists and astronomers who've been hunting for liquid water in space for decades. According to the observation published, some of the exoplanets in our universe could possibly contain as much as 50% of water. Ironically, this is significantly more than the estimated percentage of water on Earth. For comparison, water is believed to make up just 0.05% of the Earth's mass. With this much liquid flowing on the Keplers, the pressure level is expected to be significantly higher than what we experience here on Earth. To be clear, the pressure on Kepler-138c and 138d is equivalent to about 1,000,000 times our atmospheric surface pressure. With these conditions in place, it is difficult for water to exist as a liquid because any fluid present on the exoplanets would get compressed into high-pressure phases of ice, much like the Ice 7 or supersonic ices. Interestingly, these high-pressure igneous rocks are hot and hard, just like the silicate rocks within the Earth's crust. Based on the available data, scientists believe there could be more water-world planets than Earth-like rocky planets in the Milky Way. Perhaps every typical Sun-like star has one or more of these water worlds, and maybe our solar system is less typical, Li Zeng said. Generally speaking, this type of planetary system architecture with close-in rocky super-Earths and water-rich sub-Neptunes may be more common in the Milky Way than our type of solar system, he added. The Harvard University astronomer is one of the leading pioneers of the experiment that led to this groundbreaking discovery, and his comments just explain how important it is to space-faring scientists and ordinary humans that are confined to Earth. Interestingly, they share quite a few similarities with our planet. For instance, their densities lie between those of a rocky world like the Earth and the gas giant planets in our solar system. But despite the discovery of deep oceans on Kepler-138c and Kepler-138d, scientists cannot guarantee that they can sustain life like Earth does. For instance, our home planet has a known surface, but the same cannot be said of sub-Neptunian water worlds, where water compositions are estimated to range between 25 and 50% of the planet's total mass. Also, the sheer amount of atmospheric pressure on these water-soaked exoplanets means we can't dream of visiting them anytime soon.